Three resistors are connected as shown. That is resistor number 1, 2, 3. Some potentials are applied across the network. This is the potential applied across the network. Find the ratio of thermal power dissipated. Thermal power means heat dissipation between X and Y. Between X and Y, and ratio of power consumed by ABC. See, already we have seen the ratio of heat is equal to, see, H1 is to H2 is equal to H2, H1 is to H2 is to H3 is also equal to P1 is to P2 is to P3. Already we have seen it here. That is, this is heat dissipated. H3 can also be written as P1 is to P2 is to P3, which is H is equal to I square RT, P is equal to I square R. Since time is common for all the three things, so when removing this will become P. So this condition holds good. Now we have to find out what is the powers. First let us find out the power of first one. The power of resistor A. This one. Power of resistor is equal to, since power is equal to I square into A. That is current through this. So we call this is the current through this is I1. This is I2. If this is I current will flow on this one. So power of A is equal to I through I1 square into resistance of A, and power of B, this one, is equal to I2 square into resistance of B, and power on resistor C, power dissipated on resistor C is equal to I square into resistance of C. It is given A is equal to 3R, B is equal to 6R, and C is equal to R. All are in ohm. Then only it gives the indication they are a resistance. So we can write P of A is to P of B is to P of C. And what about the I1? Now we need to find out I1. I1 to find out in two branches. See, this is I1. How we can write this I1? Suppose if you want to find out in this branch, write the resistor of this one. That is 6R divided by, add these two resistance. That is 3R plus 6R into I. For this branch I1 means this divided by this plus this into I. That gives the net resistance. This is equal to 6R by 9R into I, or 2 by 3 I. So I1. Obviously I2. Suppose you want to find out here, write this one, opposite one, branch one, 3R divided by addition of these two. That is 3R plus 6R into I. Therefore I2 is equal to 3 by 9R, that is 1 by 3 times of I. And you know I is equal to I1 plus I2. 1 by 3 plus 2 by 3 is equal to I. Now first we have to write the ratio of power dissipation. Heat dissipation and power dissipation is same. So we will write heat dissipation. Power in A is to power in resistor B is to power in resistor C is equal to, how we can write power in resistor A and power resistor B. Power in resistor A is to power in resistor B is to power in resistor C is equal to what is the power in A? That is equal to, power in A is equal to I1 square into RA. What is I1? 2 by 3 of I, its square into I. Then S2, what is in I2 PA? I2 is equal to 1 by 3 I whole square. This is power is equal to RA. So this is RA is equal to 3R into 3R is to 1 by 3 into I square into R is equal to 6R is to. And what is the current through RC? RC is equal to I1 plus I2 is equal to I square into R. This is the simple ratio. We can cancel out the common term I here, I we can cancel out, here I we can cancel out, R we can cancel out, R we can cancel out, R we can cancel out. This become 2 by 9 into 3 is to 6 by 3, that is 6 by I square gives it 6 by 9, 2, this 2 will become 4 by 9 into 3 is to 1 and 1 by 3 into 6 into, this is equal to into R. How much it comes? 1 is to I square R we have cancelled, so is equal to 1. This comes out to be 1. So this is equal to 4 by 3 is to 2 by 3 is to 1. Are taking common, 3 is common, this become 4 is to 2 is to 3. Therefore, P of power dissipated in resistor A, power resistor dissipated in power B, and power dissipated in C. This its ratio is equal to 4 is to 2 is to 3, and heat also in the same ratio. So total thermal power dissipated between X and Y, between this terminal to this terminal, is in the ratio, the power dissipated is 4 is to 2 is to 3. Find heat dissipated across each resistor in 2 seconds. See here time is given is equal to 2 seconds, and heat, first of all let us find out, this is giving a current of I, this is I, it is going as I1, then I2, then again it falls as I. So first we have to find out net current. What is net current? Current is equal to potential divided by resistance net, or we can write I is equal to, what is the potential net? Applied potential is 20 volt is equal to 20 volt. What is the net resistance? Net resistance, this and this are in series, no problem, but this is in parallel. This we can write like this. With a battery, that is 20 volt, 5 ohm. What is this net? This one. So this net is equal to, we call it as R dash, is equal to 6 into 3 divided by 6 plus 3 is equal to 6 into 3, that is 18 divided by 9 is equal to 2 ohm. This is equal to 2 ohm. 2 ohm, and this is 3 ohm. Now we have converted this. So net resistance I is equal to this resistance plus this resistance plus this resistance, that is the all are in series, so we will add it, that is equal to 3 plus 2 plus 5 is equal to 20 by 10. So I is equal to 2 ampere, that is 2 ampere is current is flowing and get divided here. So when it is get, it means here also I is flowing, this at this point it get divided. So I1, we have to find out I1. What is I1? I1 is equal to, from this branch you write this one and add this both, 3 plus 6 into I. This is I1 is equal to 3 by 9. 3 by 9 I is equal to 3 by 9 is equal to I1 is equal to 3 plus 3 plus 6 into I is equal to 1 by 3 of I. 1 by 3. Is it right or not? R dash I1 is equal to this I1 is equal to this divided by this plus this, that is 3 divided by 3 plus 3 plus 6 into I, or 1 by 3I. So I1 is equal to 1 by 3 into I is equal to 2 ampere is equal to 2 by 3 ampere. And I2, current flowing in this branch, we will use this same shortcut formula, that is for this branch, write this on the numerator, add this 2 in times of I, that is 6 by 9I is equal to 2 by 3I. So I2 is equal to 4 by 3 ampere. So we have found out I1, I2, I3. Now, what is the, he is asking power as dissipated in each resistor. What is the power dissipated in this resistor? Heat dissipated. We know heat dissipated, that is dissipated is nothing but heat energy. H is equal to I square into R into T. So heat in this one 3 ohm resistor, in 3 ohm resistor is equal to a current through it. Current through is nothing but I that is I into resistance 3 ohm into I square R into T. So I square is equal to 2 square into 3 into 2. That is equal to 4 into 2, 8 into 24 joules. 24 joules. It means here 24 joule of heat is dissipated. It gets heated and it's evolved, that is dissipated in the form of heat energy. And heat dissipated in 6 ohm. 6 ohm, this is 6 ohm. I square, what is the current flowing through this I1? I1 is equal to 2 by 3 into whole square into the resistance is 6, the time is 2 is equal to 4 by 9 into 12 joules. That is equal to 4 into by 3 is equal to 16 by 3 joules. Heat dissipated in 3 ohm. 3 ohm, and in this one 3 ohm is equal to current through it. Current, we use this same formula I square R into T. Current through it is I2 is equal to 4 by 3 whole square into R is equal to 3 into I square R into T is equal to 6 is equal to 16 by 3 into 6. 16 by 3, 16 by 9. So this is equal to, which is equal to 3 times, this is 2 times 32 by 3 joules. 32 by 3. So heat dissipated in 5 ohm resistor is equal to same use formula I square RT. So how much current is flowing? The current flowing is I. So I, this is equal to I square into R into T, where I is equal to 2 ampere and its square R is equal to 5 and time is equal to 2 seconds. That is 4 into 5 into 2, 4 into 5, 20 into 2, 40 joules. It means here 40 joule heat is dissipated here, and I2 among this one is equal to 32 by 3 joule in this one, and here is equal to 16 by 3 joules, here is 24 joules. So find heat dissipated across each resistor in 2 seconds. So these are the heat dissipated: 6 ohm, 3 ohm, 5 ohm and as well as 3 ohm. three resistors are connected in series across a source, together dissipated 10 watt of power. See, first thing, three equal resistors, 1, 2, 3, three equal resistance connected across a power, that is across a EMF source, that is V. EMF source, that is R1, R2, R3, since all are equal. So R equivalent is equal to R plus R plus R is equal to 3R. And the power dissipated, power in series, we can call it as P1 is equal to voltage square divided by resistance equivalent, because here equivalent resistance we have to use because three resistors are in series. So the current will flow like this. Now P1, therefore P1 is equal to V square by R equivalent, that is we can write it as V can series, V and R is equal to 10, 3R is equal to, this is equal to V square by R equivalent is equal to 3R 10 watt. This is the first case, power dissipated is given. Now second, all are connected in parallel, same thing is connected, all the resistors are connected in parallel now, parallel with same EMF source, that is we can write this way, we can draw it with the same EMF source. This is R, and we can write P2 is equal to power in parallel. Then R equivalent we write, because all are equal resistors, we can take any one of the resistor divided by number of resistors, this is R equivalent. R equivalent is equal to R by 3, which is equal to R equivalent is equal to R divided by 3. Now power, what about the power? The equation of power is, for the power 2 is equal to, what is the voltage here? 3 V square by R. This is V square by R equivalent. V square by R equivalent or P2. Or we can write, see from here we can write V square by R from this equation. From this equation, V square by R is equal to 10 watt. So P2, what is P2? P2 is equal to V square by R equivalent, that is V square divided by R divided by 3 is equal to 3 into V square by R. V square into 3 by R. Or V square by R is equal to, here V square by 3R is equal to 10 watt. Okay. Now here V square by R. What is V square by R? V square by R here. Is it right? V square by R equal to V divided by 3R is equal to power dissipated 10 watt. Okay. So V square, we can write V square by R is equal to 10 into 3. This will go here 30. V square by R. Or we can write power in parallel is equal to 3 into 30 is equal to 90 watt. So power dissipated in series, when these three resistors are connected in series, the power delivered is equal to 10 watt, and power in parallel when they are connected it gives 90 watt.